Alright, now we'll spend quite some time playing with the Robot Kaya example. It comes bundled with MPS, so if you install MPS, you should have it on your computer available to play with. Simply when you start MPS, go to Open Sample Project and then pick Robot Kaya project from the list of samples. And after opening, your screen should look like that. Now, probably since you are beginners, I recommend that you click this little button in the bottom left corner. So then these helpful tool buttons, that each of them hide some sort of useful panel. So these are now available and visible. When you click on them, a window shows up and disappears. Now when you click on Project, which you can open by the Alt-1 or Command-1 on Mac keyboard shortcut, that gives you the structure of the project. This project holds 5 modules. 2 of them are solutions, 3 of them are languages. The most important at the moment for us is Sandbox, because this is a place where you can experiment with code as you develop your languages. So here we can see a few sample scripts written in these Robot Kaya languages. The language allows you to command a robot. I'll first run the script so you see the effect of it. So if I right-click on any of the scripts and pick Run Node, then a Java application is started that will run the code, the Java code that was generated from the robot script. So it creates this visual scene. There's a robot on it, and in the corner, and it will follow my instructions written in the script and walk around the scene. Now let's look at the code itself. So the script consists of commands, and you can see commands that instruct the robot to either make a step forward or to turn left, and there are a few more, like to pick an item from where the robot is or drop an item. Then you can find the typical control flow constructs like while a loop. So if you want to have conditional loop in code, or you can find if statements with condition: if there's a wall ahead, do this, else do something else. You could find repeat, although not in this script, so I'll just add it. Repeat several times, and now whatever you want to repeat. This language also supports in-language abstractions, so that the author of a script can also create abstraction. They don't have to ask language designer to introduce new commands for the robot each time they want to have a new command. I'll open another script here. So the script is now empty, and suppose I want to turn the robot around. So the only turn command the robot can do, well, if I do Control Space I get code completion, and here I see all the commands the robot can do, and the only commands that allow me to turn the robot is turn left. So if I want the robot to turn around, I have to repeat turn left twice. I can either just type repeat 2 times turn left, or I can actually rely on the language to tell me that that's probably a wise thing to do. Notice this yellow underline here, it's telling me, hey, you're repeating yourself. If you hit Alt-Enter, there's an intention for you that can fix the issue here. We can replace the repetition of turn left with a repeat 2 times turn left. So the language can also encourage good code practices to through these intentions and hints to the user. Now, not only that, the in-language abstractions allow me as a robot script author to create new commands for the robot without actually changing the language definition. So I can use the language as it is. I just create a new routine, turn around, and the routine will do the, will contain the code to turn the robot around, turn left. So I've got a routine, and now I can use it. So now I've got a new command for the robot called turn around. That I can use. So this is called in-language abstraction. This language allows very simple in-language abstractions called routines. General purpose languages provide more capable in-language abstractions such as classes, interfaces, and such. So it really depends, you may design your languages to contain in-language abstractions or not. Now, once you have things in your language that represent definitions of some sort, you also need to have references to these definitions. And the IDE gives you the ability to visualize references that go across the tree. So if I hit Control B or Command B on Mac, and I'm positioned on a reference to some definition, the cursor will move to that definition, and the definition here gets highlighted. When I am on a definition of a routine and hit Alt F7, search for usages, I'll get a search window with all occurrences of references to my definition, and I can click on those and the editor will highlight these for me. And these references will be also shown if they refer to this routine from other nodes, from other root nodes. If you decide to change name, then you just change the name. Since this is the references in MPS are live, whenever you change the name of something, all the references to it get updated as well, because the name is stored at one place anyway. It's at the definition, and the pointer, the reference to it, will just accept the name as it is at any moment. Well, now how about the generator? Now this code has somehow be run. In order to run it, it gets translated into Java. And you can always preview the generated Java. If you right-click here in the editor and pick Preview Generated Text, the generator will run and will show you the code that is generated from the model. So we see a Java class that implements our little robot script.